we are basically entering the final act of BGP EVPN, which is the L3VNI, right? We have talked about L2VNI, and what we have done till now is this. We have been able to establish, connectivity between, the within the same L2VNI, right? So you can see the blue one over here. We have been able to establish connectivity here, and we have been able to talk between, talk in the red L2VNI, right? So now we are moving towards the L3VNI. So this is where routing comes into play. Till now, whatever we have done, right, in one single term, if you want me to put this is nothing but what we call bridging, right? We have been able to bridge. So we have bridged, from in this particular VLAN 10 over here. I mean, I did use the VLAN 10 on both the sides, but it need not be. But mainly we have been able to bridge in this particular VNI as well as in this VNI. And we looked at the whole, the routes, how the whole control plane works, how the whole data plane works, right? Awesome. So let me just get rid of this a little bit so that we can now talk about the L3 side of it. So when we talk about L3 side, right, what we mainly need to think is basically in terms of the L3VNI, right? And what is this? What is L3VNI, right? Remember, while talking about L2VNI, I did mention a couple of things, right? I talked about your regular IP VRF, and I also talked about the MAC VRF, right? So hope these two things are fresh in your memory, right? Because we'll have to correlate all of these when we move towards our L3VNI, right? So again, to just give you this thing kind of like a refresher, IP VRF is your traditional VRF, whereas MAC VRF, think of it as, a MAC address table for every L2VNI, right? And you remember the diagram which I put in, while explaining this, right? Cool. Now, what VXLAN or what BGP EVPN brings to the table when it comes to routing, right, is what we call as IRB, integrated routing and bridging, right? So this is a very cool functionality of your BGP EVPN, where every single node, every single VTEP, right, has the capability to do both, right? We did bridging till now, so you know how the bridging works, but it has the capability to do routing and bridging. So that's why we call, this functionality or this cool feature, we call it as integrated routing and bridging. All right. Okay. So that being said, now comes something very interesting, right? So when we talk about integrated routing and bridging, right, probably will not find this in much of documentation, but it's very important to know there are two types of this. One is called asymmetric IRB, right? And the other one is basically called symmetric IRB, right? This is a really cool concept, right? Asymmetric integrated routing and bridging and symmetric integrated routing and bridging, right? Let me just clear my screen a bit. Give me a second. All right. So let's start with asymmetric one, right? This one. So the asymmetric IRB, what I'm going to do is I'm going to take my whole VXLAN and I'm going to split it, right? What I'm going to do is let's draw a little simpler topology than that. So I'm going to have spine 1, spine 2. I'm going to have my leaf 1 and I'm going to have my leaf 2, right? How are they connected? Pretty straightforward. All right. Now, what I'm going to do next is I'm going to take each of these VTEP which I have and I'm going to again break them down, right? So what I'm going to do is let's put the components of this VTEP in this box and probably the components of this VTEP in another box here, right? So what are the various components? You already know them, right? We have used them in our L2VNI discussion. One of them is our NVE, right? So you've got my NVE. NVE is nothing but my logical, it's nothing but a logical interface which represents our VTEP, right? Next, what do we have? We have our MAC VRF. Remember, we talked about MAC VRF. Yes, there is going to be a MAC VRF, right? Now, remember, MAC VRF is nothing but a MAC table for every L2VNI, right? As simple as that, for every L3VNI. So I can have multiple MAC VRF, right? Because I'm gonna have, I can possibly have multiple L3VNIs on this guy, right? You can probably have a L3VNI, say, I don't know, 5,000, right? And probably this will be 6,000. This is going to be representing VLAN 10. This is going to represent VLAN 20, right? Similarly, on the other side as well, I can have multiple MAC VRF. So here, say for simplicity, this is 10 and 20. I'm going to make this guy 20 and this guy 10, right? So it's to just have a little bit of symmetry. So, you know, the L3VNI is going to be same as this. So because this is 6,000, this one will be 6,000, and this is 5,000, so this will be 5,000. Right? The L3VNI has to be same. The VLANs can be different as well. It need not be 20. I just kept it as 20 just for our reference, but it need not be 20. Sweet. Okay, so, and the last component which I also want to put here is a small router symbol. Why? Because we are talking about IRB here, which is nothing but integrated routing and bridging, right? So think of this router as nothing but your Anycast Gateway, right, which we have talked about till now. So what we have right now, we just have L3VNI, we have the Anycast Gateway, and we have NV, nothing, right? We don't have L3VNI, and in our asymmetric, integrated routing and bridging, there is not going to be L3VNI. It's only L2VNI, right? So there is no L3VNI, just to double click on that. Okay, so now how does the forwarding work, right, in such a scenario, right? How does the forwarding work? Very interesting. So what happens is, let me use a different color, right? So imagine, imagine I have a server over here, right? I have a server connected to VLAN 10 here. Let's say the server SR1, and I have another server, probably let me use a different color, which is here, and that is server 2. And I want to, what I want to do? I want to talk between these both guys, right? So what I want to do, let me just reduce the size of this. I think it's just going about, okay, hope that's visible. So what I want to do is I want to talk between these two guys, right? I want to talk. So what is happening is I want to really talk between the L2VNI 5000. I want to talk to 6000. See, it is not intra, it is inter L2VNI, right? You are talking to a different L2VNI altogether. We have not done this till now. In our previous discussion, we talked within the same L2VNI, right? We talked within 5000, we talked within 6000, but now we want to talk from 5000 to 6000. So it's a inter, right? This is where routing comes into play. Now, how does that happen in asymmetric IRB? Is that, what is the first step here? Let's trace this. What is the first step? Let me probably trace it this way, right? So first step is this server 1, right? So let's put some, IP addresses to make this simpler, right? So obviously this is in our L2VNI, so let's probably use something like 10.1.1.1 as the IP address. Here, because it is a different L2VNI, so I'm going to use 20.1.1.1, right? Now when you want to talk between these two, the server 1 realizes that 20.1.1 is not in its subnet, right? It's in a different subnet. So it is going to what? Send the packet or bridge the packet to the default gateway, right? To its default gateway, to its Anycast gateway, right? So that's why the first packet is going to be in this way, right? The packet is basically it's going to be bridged, right, from the server to the default gateway. That's why I put the router here, just for simplicity. So that's the bridging part. Now, the Anycast gateway, right, will look for the destination, which is my 20.1.1, and it realizes that this 20.1.1 is in L2VNI 6000, right? So it has to now, let me use a different color for this. So it realizes now that it has to route into the MAC VRF, this particular MAC VRF, right? Because it is in 6000. So it is going to route it. What we did first, we bridged it. Now it's going to route it. So it's going to route it into, right, into the MAC VRF that has the information about this 20.1.1.1. Awesome. What is next? Now once we are here, right, isn't it nothing but the same L2VNI 6000. So it's the same process like we did last time, right? We are now talking between the same L2VNI. So this process is again going to be bridging. There's no routing here. This is bridging, right? Because you are talking within the same L3VNI, 6000 and 6000, right? So if I have to put this down, what did we do? We bridged, then we routed, then we bridged, right? So this process or this way of forwarding is what we call asymmetric. Why it's asymmetric? You can see it is bridge, route, bridge, right? And once the packet comes to this L2VNI, it can easily send it to the SR2, right, which is the server 2. The same process happens in the opposite direction as well. So in that case, this is what happens. So this guy, let me use the same colors probably just for simplicity. So when SR2 wants to talk to SR1, it's obviously going to bridge here to the default gateway, right? This guy will realize that the SR1 is in a different MAC VRF, so he's going to then route it to this guy because 5000. Now the 5000 has to talk to 5000, so it's going to be from 5000 like this, right? So you see, it's a very the reverse direction is also very same as the forward direction, but whatever it is, we are always doing bridge, route, bridge, bridge, route, bridge. So that's why it is asymmetric. Now let's talk about the let's talk about the symmetric one. Right now, wait, before we go to the symmetric one, you understood the process, but what are the disadvantages of this? The disadvantage of this is that you require each of the VTEP, right? Each of this VTEP to have this MAC VRFs, right? So in this functionality or in this asymmetric IRB, it is compulsory or mandatory to have the MAC VRFs, all the MAC VRFs on all the VTEPs. Otherwise, you'll never be able to do this routing, right? If you did not have this MAC VRF, so you'll never be able to do routing, right? So in asymmetric IRB, even if you don't have a client in that L2VNI, still you would need to have the corresponding SVI, which is the Anycast Gateway, and the corresponding MAC VRF on that VTEP, right? So that is a disadvantage, because as you scale, right, creating so many MAC VRF MAC tables is not going to scale. If you have say thousands of VNIs, it basically means that every VTEP should now have each of this MAC address table. Really not a good way to go about it. So Cisco's way of doing this is slightly different. This is asymmetric IRB, but Cisco's way is what we call as the symmetric IRB, and that's really cool. So the same stuff remains, right? The topology is same. The only difference is I'm gonna again draw this part, and I'll show you how each of the components play a role here. So this is your NVE, and you have your MAC address table, right? This is for your 5000, this is for your 6000 VNI, L2VNI, right? This is your L2VNI again, and this is your L2VNI 5000, right? Very same, nothing new. Give me a second. 10, 20, 20, 10, right? I have drawn the exact, I've replicated what I had here, but I'll show you where it clearly differs, right, in symmetric one. Now in a symmetric one, there is one additional piece, which is your L3VNI, right? Just to send that message, I'm going to clearly mention here, no L3VNI, right? Where in my symmetric, in my symmetric IRB, there is no L3VNI, but here there is L3VNI, right? This is in my symmetric IRB. There is. So what is L3VNI? L3VNI is nothing but another VNI, which is nothing but VNI is nothing but an identifier. But now what you do is in symmetric, you create a VRF, right? You create your IP VRF, a normal VRF. These are your MAC VRFs. We create another, I'm going to clearly call it out as an IP VRF, right? So we are going to create an IP VRF, and we are going to attach that to this, to all the various L2, VNIs or the VNIs which are basically associated with it. We are going to attach it this way. I'll show you how to do the configuration, but you are going to have that IP VRF on both the sides. right? And this IPVRF is nothing but my L3VNI. So we are going to have an identifier and we are going to attach that to the IPVRF, and that will be kind of like connected to, associated with all the L2VNIs under it, right? Cool. So this is like the only small structural change. Now let's trace it. How does it work again? Same example. I want to talk between VNI 5000 and 6000, right? What happens? First step is still bridging. Let me use the diagram. So first step is still, okay, I did not do the routing piece. Give me a minute. So I'm going to put a small router here, Cool. So first step, my client sitting here, the server one is going to bridge to the default gateway. That's how it works, right? Whenever I have to talk to someone in a different subnet, because here it is 10.1.1, this is 20.1.1, I have to bridge to the default gateway, right? And the default gateway will take care of the next step, because I won't be ARPing. I'll still be ARPing, but I'll be ARPing the default gateway. I'll be sending my packets to the default gateway and he'll take care of the routing path. So I'm going to send it to a default gateway, right? But this time, what happens is that the default gateway will do a lookup for whom? This particular, this guy, this is 20.1.1.1, right? So the default gateway or the Anycast gateway which I have here, right, will do a lookup for this one. We'll do a L3 lookup, right? And what it will do next is it will use the L3VNI which we have set up, right? So we have set up a L3VNI. It will use the L3VNI to route the packet, right? So let me use this one. It will use the L3VNI to route the packet directly onto the other side. I mean, obviously it will go through the NV, but just for simplicity, I'm gonna, mention it this way. So it's gonna bridge, and the first step is the bridging. Then you have the default gateway which will look up for 20.1.1, right? And that destination will be present inside my VRF, because during my BGP EVPN, right, the exchange would have happened, right? All the routes, all the host routes, all of that would have been exchanged, and they will be now associated, they'll be put inside this IPVRF table, right? So when it is doing a check, or when it is looking out for 20.1.1, it finds it in the IPVRF table, because we have a new construct here. We have a L3, routing table. We have a VRF routing table. So it will look up in that, right? And that's why I kept on saying that, the Anycast Gateway, the L2VNS, all of them will be associated with this VRF. So whenever it finds a destination IP address to look for, it is going to look for in this IPVRF table, and it is going to find it, and it is going to encapsulate it, do the whole VXLAN encapsulation using the NV and send it across to the other side, right? Now, once this guy gets it, right, the other side, when the leaf 2 gets it, it will do a routing lookup for whom? 20.1.1, right? And it will realize, right, that this one is kind of like reachable, right? It obviously it is going to find 20.1.1 in its VRF table as well, right? So it's going to route. Give me a second. My pen is not working again. All right, it's back. Yeah. So where was I? So the VTEP 2, which is the second VTEP here, once it gets the packet, it is going to look for 20.1.1 and it is going to route this, right? So I'm going to use the same color again. Maybe, I think that's better. So it's going to route this into this particular, VLAN, right? Locally it is VLAN, right? VLAN 20, right? And because it knows that, this 20.1.1 can be reached via this VLAN. So it's going to route it. And once it is routed to that VLAN, it is going to bridge it to this, because, inside the VLAN, if you want to reach to anyone, it is going to be a bridging, right? So yeah, so that's the whole process, how it plays around. Now, if I have to write this process, first we did a bridge, then we did a route, then we did a route, then we did a bridge, right? Now, doesn't this look more symmetric, right? We have BRRB. So that's why it's called as a symmetric IRB, right? Now, there are a few changes in the constructs which I said, right? But to understand the implication of this is really cool. So what we ended up doing is that you see we have not used, let me just draw this, we have really not used this guy, have we? Right, unlike here, we have really not used this MAC address table or this particular SVI or this particular VLAN. We have really not used it on the source side, right? And on the similarly, when the return packet comes, right, we will not be using this guy as well. So what we have really accomplished here is that we have been able to route the packet between the two L3VNIs by not really having both the L3VNIs on both the tables or both the VTEPs, right? So that's really cool, because now I can scale this, right, by just having the L3VNIs to which I have some clients connected. If I don't have a client connected to it, right, in this case, let's say I really did not have a server which is connected to L3VNI 6000 on my VTEP, then I really don't need to even have this table, right? I just put it here for simplicity because I wanted to show you the same topology. But if I really don't have a server connected to this L3VNI, I really don't need to even have this. So that really changes a lot of things. Now you can scale this, which means in symmetric IRB, you can now have only MAC address tables to which, or you can just have the VLANs and the L3VNIs, for which you really have the servers connected. The ones which you don't have, you don't even have to create, because it is not even going to be used in the data path for your routing, right? It's not used, because what happens is packet directly gets routed from this VRF which you have now created, and it goes to the answer. Now you might ask a question, okay, we are removing this, but aren't we adding one more VRF? So doesn't that kind of negate, right, nullify the impact? Actually not. I mean, in this topology, it might look that way, but imagine when you're scaling this. When you're scaling this, what happens is if you have, say, something like 1000, L3VNIs, right? What you have to think of now is that we are basically, in this older example or in this asymmetric IRB, we will end up having all these 1000 L3VNIs on all your VTEPs, right? But now in this newer symmetric IRB, you can just have the L3VNIs which you really need. Maybe on this one you will have from 1 to 500, and maybe from here you're going to have from 500 1 to 1000, right? So you just have probably half of the L3VNIs and plus one L3VNI, right? So isn't this a bigger difference, right? You just have 500 L3VNIs and one L3VNIs versus having all the 1000 L3VNIs on each of the VTEPs, right? So that's a major shift, and that's what Cisco uses, for routing between the L3VNIs in case of VXLAN BGP EVPN. Hope this was clear, right? So I just want to spend more time here because it's a really cool concept. That being said, I think we can now jump on to the configuration, and we can see how we can route between these two cool VNIs. Give me a second while I clean my screen up, and we'll start with the lab. All right, just to again reiterate, what we'll be doing is something like this. So we have 10.1.1.1, we've got 10.1.1.2, we've got I think 10.20.1.1.1 and 10.20.1.2, right? What we have done till now is this. We have been able to talk between this guy and this guy. What we'll do now is we'll be able to talk between these both. In fact, we'll be able to talk between anyone, right? That's what we are heading towards, because we are basically going to be doing routing between this and this. It's going to be routing between this and this. It's still going to be bridging, right? Because it is in the same L3VNI. Between the last one, again, it is going to be routing, right? And we have done the bridging till now. We'll be doing this and this, right? So hope that's clear. So let's get to the configurations, right? Pretty cool configs. So nothing on the spines. So we don't have anything to do on the spines. We just need to do some stuff on my leaves, right? So let's pick that config. So I'm gonna do that. Let me just get rid of this. And okay, so there you go. So what we'll do is we'll first create that L3VNI. Remember the L3VNI, So the L3VNI which we will use is, I think we'll use 1000, let me just write down that. I think I don't have my pen, so I'm going to just write it down here. So we are going to use 1000000, probably 100 and 999, right? That's a very small, just increase the size of that a little more probably. Okay, so this is going to be what? Our L3VNI, right? Yeah. So, and for now, what we are doing is we are assuming that the whole VXLAN domain is used by only one customer, only one tenant. But it is, you see, because when I create a L3VNI, I can similarly create multiple L3VNIs if I want to support multiple customers, right? You're getting the picture, right? So you can now host multiple customers in your data center using this. So that's why we say VXLAN is multi-tenant, right? So now let's say this L3VNI is representing customer 999. I can have another customer representing, I don't know, 888, and I can create one more L3VNI and associate the corresponding VLANs of, you know, for that customer into its L3VNI. So it's very simpler to scale, to do it multi-tenant and do all of that. So it's really cool that way, right? Awesome. So let's start. So we'll start with the leaves. I have my first leaf, which is N3, right, from the topology. So first thing is we are going to create our L3VNI. So we'll have to create this guy on probably all of them, right? So this is how I create it. I create this is my actual L3VNI, but whenever you create an L3VNI, you will also have to create a VLAN for that as well, right? So because you'll have to associate this L3VNI with the VLAN as well. So that's why we have the VLAN 999. Okay, so you'll understand more as we proceed, and now we'll have to actually create the VRF. Remember, so we'll have to actually create the VRF. So I'm going to create VRF context. I'm going to say tenant 1. You can give any name you want. I'm going to associate this L3VNI which I created above to this VRF. There you go. I've done that. Now we'll have to just do the regular, you know, VRF configuration, the route distinguisher and the route target, right? So you see route distinguisher is auto and route target is also auto. And remember, I'm doing route target auto and route target auto EVPN. So I think it's stuck. Give me a second. All right, sorry about that. Yeah, so route target is very interesting here. I think this is why I just wanted to re-emphasize here. So just to double click again, in what where are we in BGP EVPN, what happens, the route targets plays a very important role, right? So you have route targets for both your L2VNI and L3VNI. Now for L2VNI, the route targets we have already defined, right? When we did the L2VNI configuration in the previous video, we have defined the L2VNIs, because route targets in that context is going to be very useful for the VTEPs to download the MAC addresses concerning only the L2VNI which is configured on that VTEP, right? So that's the use case of route target in a L2VNI space. Similarly, the route target is also needed for L3VNI, right? And this configuration here, route target both auto EVPN, is basically going to do that. It's going to create route targets, right? So that when the in the control plane, right, when the BGP updates are shared, right, when the MP BGP updates are shared, the the VTEPs will download the L3 information, the L3 routes, right, based on the configuration, based on this based on the route targets, which is configured because of route target both auto EVPN, right? All right, so just to again picturize this, right, let me just put this configuration and you could go back to my diagram. Just to picturize this, what happens is that when this VTEP is advertising, right, in the BGP update, when it's sending the BGP update, it will say that 10.1.1, right, and its corresponding MAC address, I don't know, maybe it's MAC 1, right? These are the routes, right? Remember I talked about type 2 and type 5 routes. So these are the routes which are there in my EVPN address family, right? So type 2 routes is nothing but a MAC address or MAC plus IP, whereas type 5 is like a prefix, right? So these are the various routes. You can again go and dig deeper into the various route, the format and all of that, but on the surface, these are the various routes which are employed in our BGP EVPN, right? And when my VTEP1 is advertising, sending this BGP update, it's going to say, hey, look, 10.1.1 is going to advertise with a particular route target. What is the route target? It will be the L2VNI route target, and it also advertises or adds the L3VNI route target, right? Because we are using symmetric IRB, right? So this L3VNI also will have a route target because of the configuration just now what we pushed. So it is going to send 2 route targets now, saying that, look, this is belonging to L2VNI, whatever the number is, right? And it is also going to say this particular host, right, is also part of this tenant VRF, which is L3VNI, which is 1000999, right? So that is the need, for the route targets in the whole BGP EVPN. Now you would have also seen me putting another route target. You can see there's route target both auto. Now why have I done that? That is, whenever you have a route target without the EVPN keyword, it means that this is for your VPN v4 table, right? Your regular MPBGP VPN v4 table. Why have I put here? The reason is, this is all good. This is your data center, this is your VXLAN, but at some point of time you would want to exit this VXLAN and go to an outside network, right? You can't really be talking only here. You would probably want to connect one of your leaf to a, I don't know, probably a core router, right? Maybe a ASR 9K, and then probably that would then connect to a transport like MPLS or maybe SD-WAN or something like that. So you would really want to go out, right? So you should have a way of talking between your EVPN address family and probably a VPN v4 address family, right? So because in the outside world, EVPN address family has no significance. VPN address family has significance only inside your VXLAN domain, only inside your BGP EVPN domain, which is only this data center or these bunch of devices. But outside, when you're connecting to something to outside, right, for exchanging routes between that, right, you would need the regular address family, which is VPN v4, and in that case you would need those routes to be imported and exported based on a route target. So that's why you have this. Now again, you can probably configure this manually. In fact, if you have your setup as a eBGP setup, then probably you would need really manual configuration. But since I have a iBGP setup, I can rely on my iBGP to come up with the route target values, because there are some predefined rules on how it comes up with. So I can rely on that, and it is going to do the job for me, right? Because it is going to automatically generate something, and that's going to be the same on all the all the VTEPs. But if I have eBGP, then the AS numbers are going to be different, right? So in that case, I can't really rely on this guy, because then it would generate the different route targets. Then what I'm exporting, I'll not be importing, and it'll screw up a lot of stuff. So just keep this in the back of your head. iBGP, you can use the route target auto, but if you're using eBGP for your overlay for your BGP EVPN, then you would probably need to manually configure it. Sweet, that is done. Next, what we do, we have done with our L3 this thing. Now let's go, because we have created this VLAN 999, we'll have to create a SVI for that as well and put that in the corresponding VRF, right? So this is all straightforward stuff, right? Sorry, did I lose that? Yeah, that's good. So now, what we have done, we have just done 3 steps, right? We have created VLAN 999, we have attached it to the L3VNI, then we went and created the tenant, the VRF context, which is the actual L3VNI, where we have associated the L3VNI, we have done the route target configuration. Then we also created the SVI, because for routing you can't do routing using just VLAN, right? You want a routing interface on that particular switch, and this is doing that job for you, right? And remember, I kept on, while talking about symmetric IRB or asymmetric, I kept on saying the routing construct over there, that is nothing but this SVI, which is doing that, right? So once that is done, I already have my NV interface, right? What I'll have to do, remember this NV interface, it's already there. The only step I have to do is the new VNI which I have created, the L3VNI, I'll have to just associate it to the VTEP. We are basically telling VTEP, hey, you have a L3VNI now. Till now it was not there, we were using L2VNI, but now we are associating that particular L3VNI which we just now created to the VTEP. because we have to tell the VTEP, right? All the VNIs which are associated with them. So that is pretty much it. I think apart from that, okay, so do we want anything else? I think that looks good. Okay, the other thing is, okay, I think there are a couple of things which we'll have to do. We'll have to add a little bit of the BGP configuration as well. We have done BGP before for L3VNI. We'll have to add a bunch of stuff, right? Now, this part of the configuration, I believe, has been kind of like removed in your newer versions of Nexus. I am not completely sure. I'll have to verify, maybe in your 9.x release. But because I'm using 7.x, we'll have to manually do this, right? So what I'm doing here is nothing but, the network part you will still have to do. What I was telling is this particular command, right? Advertise L3VPN EVPN, right? So this advertise command, I think, is implicitly done in my new version of Nexus, right? But this is again pretty straightforward. I already have my BGP. What I'm doing now is I'm basically enabling that particular VRF, the L3VNI, in that BGP instance, right? Otherwise, there won't be connectivity. There won't be, the BGP process will not know about the L3VNI which I created. So it's very, the process is pretty simple. You go and create your L3VNI, you associate your VRF to it, you associate a SVI, to that particular L3VNI, and then you go and associate the VTEP to. You basically go and associate all your various. It's all about interconnecting your various, constructs to each other, and that's pretty much it, right? And the network, just observe this 10.1.0, right? This is the network which I'm advertising because I'm on switch. I'm on leaf 3, right? I'm on this guy. So this is the subnet which I'm advertising, inside the address family for the connectivity, right? So that's straightforward. The other part is the Anycast Gateway, right? So we have the Anycast Gateway. Remember, we have do show run. Okay, I don't have to do here because it's a Nexus, so I can do just like show run section. I think interface VLAN 10. Sorry. Maybe I can just do this. Show run interface VLAN 10. There you go. So I have my VLAN 10 which was already created, right? As a Anycast gateway, right? I had already created it for L3VNI, but it was not really useful over there because the traffic was never going to the default gateway, right? The ARP was happening on the host itself. But now, since the traffic will be going here, the VLAN 10, I'll have to associate it with the VRF. Very much, I think I removed the diagram, but you understand with respect to the diagram which I drew earlier, right? We'll have to associate those various VLANs up to the L3VNI or the VRF. So it's all about connecting the dots. That's it. So we'll have to go and associate this particular VLAN to the VRF again. So we're going to paste that. The rest of the config is pretty simple. I'm adding the IP address again because whenever you connect or whenever you associate an interface to the VRF, all the configurations gets deleted. So I'll have to re-add the old configuration. That's why I'm just adding them. Cool. So I've explained in detail for one of the switches. For the rest of the switches, what I'm going to do is, okay, I'll have to log in, I guess. I'll have to send to all connections. Okay, that's good. Let's log in again. Okay. So we are done with N3. Let's actually do N5 because that's going to be very similar as N3, right? Why? Because if you see, they have the same subnet 10.1.1. They have the same L2VNI to be per se, right? So I'm going to do this and then we'll come back to the rest. So we're going to do Nexus 5 right now. Pretty simple again. Go and say conft. Right, so now I'm going to show you the complete config in one single this thing, so it's easier to visualize, right? So you see, you have the VLAN 999, which is your VLAN created to support your L3VNI, and then we are creating the VRF, right, and associating the L3VNI. I explained to you about the route targets. This is going to be the SVI, right, needed for the routing, which I'm associating it to the VRF which we created above. we have the NVE interface. We are telling NVE about the new L3VNI which we just now created. We are going to router BGP and advertising the network which is 10.10 1.0, right? Without telling it, probably you can do something like redistribute connected, maybe. I think that should work as well. But I'm explicitly advertising the network. And we have the interface VLAN 10, which is the SVI, Anycast Gateway, right, for this particular subnet. And I'm basically associating that also with the VRF. Otherwise, you know, so once you create a VRF, you'll have to basically associate all your existing constructs to the VRF. Just remember that. So that's done with 5, and let's quickly go and do N4 and N6, right? So that's going to be pretty simple. So let's see, I have the configs here. So let's do N4 here. Again, pretty simple. Only the difference here is the subnet which I'll be advertising is 10.20, right? And the VLAN it's going to be 20, right? Because it's the leaf 4. So I'm going to paste that. And let me also paste the last part which is on N6. There you go. Once that is done, I'm just going to click on enter. Right, so that looks good. So looks like all the configurations have gone in, which is always a good thing. So let's do a bit of validation here, guys. So let's see if what do we see. So if I do show BGP L2VPN EVPN VNI ID and 1000999, the L3VNI, let's see what is happening with L3VNI. There you go. So we have the L3VNI visible. It is visible on N6. It's visible on N5. On 4 and 4 and 3 as well, right? There you go. So it's pretty much visible, which is a good thing. Now ideally we should have the connectivity, but what I'll do is give me a second while I set up the captures and I'll come back. All right, so I've set up the captures needed. On the top 2 will be the interfaces going out of the leaf towards the spine, and the bottom is the capture which is going towards the host, right? So basically these both are the interfaces going towards the spine, and the bottom one is this one. Now let's play around with this. Before that, let's analyze the output which we just now saw. On any of this, if you go, you will basically find interesting thing. See, the route type 2 is there here, and then you also have type 5 route here. Right, so we are on leaf 3, and on leaf 3 you can see the type 2 routes will basically be for what? Will be for the MAC address, which is this 10. Let me just check that. Give me a second. It is 48-bit. All right, perfect. So if you see here, I just was looking for this command. Remember I told you in the previous video, this is a command which you need to run if you are doing this on Nexus 9000V, because show MAC address table will not return anything. So this is the command to look at the MAC address table, and you can see the directly connected host is nothing but the MAC address ending with 6808, right? So that is nothing but 10.1.1, but you see the rest of the MAC addresses and the corresponding IP. So these are nothing but your MAC plus IP, right? Those routes are visible here, and they are all your type 2 routes, right? And this is basically for 10.20.1.1, 10.10.1.2, and all of them are visible here because I have piped in the L3VNI, and all the leaves currently are belonging to the same L3VNI, right? So you can see all the end hosts are visible here. They have been exchanged. BGP updates have gone in, and this information has exchanged, and all of the end hosts are known to me. You also can see the type 5 route here, right? You can see the type 5 for 10.1.0 and 10.20.1.0, and that will basically go as type 5 route, right? So this is basically the internal workings of your BGP updates and the route types, how they are exchanged and all of them, right? Pretty much the same you will see on all the guys. Now that and the other stuff will still remain, right, which we did in the previous one, like for example the L2VNI. Remember, this was the L2VNI on this guy. So L2VNI routes are still there. They have not gone, right? And I will not be able to see the L2VNI for the other L2VNI because I don't have that particular L2VNI configured on this guy, right? So it will return empty. There you go, right? So the for VLAN 10 or the L3VNI corresponding to VLAN 10 is nothing but this, and I have output for that because I have a client connected to that guy, right? I have that L3VNI configured. Because I don't have this L3VNI in my VTEP, I don't see any output for that. So I hope that clearly clarifies. This is the routes which are exchanged as part of your L3VNI, right? And these are the routes or the BGP EVPN routes which you will see when you pipe in the L3VNI. That being said, let's play around. Now we'll go and do a ping. Where are we? On host 1, right? So on host 1, let's try to first check the old functionality, which is trying to ping within the same L3VNI, which is 10.1.1.2, right? I am 1.1, so I'll have to ping 1.2, and there you go. The L3VNI works. We can just double verify the packet captures as well. There you go. The ICMP request is there, and you can see inside the VXLAN, the VNI which is used is 1001010, which is your L3VNI, right? So there you go. ARP was sent, and the ARP reply came back, right? Pretty straightforward, nothing complicated. We have looked into this before. Now let's do the other one, right? For which we did all this extra work, which is will we be able to talk to the server in the other L3VNI, which is 10.20.1.1. Do you think will this work? It should, because we have now configured the symmetric IRB or the L3VNI, right? So I'm talking to, I am 10.1.1, sorry, 10.10.1.1. I'm talking to 10.20, which is in a completely different L3VNI. So it's going to use, there you go, it's working. Let's see the captures. Looks like the packets were sent from this side, from this, and you can see from 10.10 it has gone to 10.20, and let's look at the VXLAN here. There you go. You can see it is using the L3VNI, right? It's not using the L2VNI, it is using L3VNI because it is using symmetric IRB, right? Cisco has implemented symmetric IRB and not asymmetric, because symmetric is more scalable. Remember, we don't have to have all the L2VNIs on all VTEPs, which is really a good thing. It's easy to scale. You don't have to have huge MAC address tables now. You just need to maintain the MAC addresses of the L2VNIs which you are having on your VTEPs and not anything else. Sweet. So I think that was mainly with respect to this. I think I've probably covered everything. We could probably look at the BGP updates if you want. Let's see if the BGP updates are going in. There you go. I can see an update here. The path attributes here, the MP reach NLRI is here, right? And if you see the information which is carried inside that, you can see there is a MAC address advertisement, right? And you should see the value. The route targets also should be sent somewhere here. I think it will be sent as an extended community. See, you can see the extended community here. There you go. The route target this is for this is, which one was I seeing? This one was basically going in from the to destination 192.168.0.3. Okay, so this was going from 2 to 3. So yeah, so I think this was an update which came from the route reflector towards my leaf one, but obviously and you can see the route target, which was, where is the route target? Sorry, here, yeah, there you go, the route target, right? Here I can see the route target here. So this route target is auto generated since we have not explicitly manually configured, right? So you should be able to see the values, right? It basically does the route target, it picks it from the AS number, which is my 64520, and it attaches the L2 VNI for that particular. So this is a L2 VNI's corresponding route target, right? You can see that here. Awesome. So you can similarly investigate the other update packets to look at, what is being carried, and you'll basically get to know more. You'll get a better understanding about, all your attributes and stuff like that, right? So that's mainly it, guys. Hope this was a useful session where we covered everything from, your BGP EVPN. We started with a brief, and we ended up doing the L2VNI. We talked about before that we talked about why we need VXLAN, right? And we talked about the control plane learning, data plane learning. We then double clicked on control plane learning, where we dug deeper into how MPBGP is kind of like used here, how EVPN kind of introduces the new address families, new route types, right? Type 2 route, type 5 route. We looked at the BGP update messages. We looked at the data plane, right? How VXLAN encapsulates the significance of the UDP header. We talked about that. And we looked at when you're talking within the same L3VNI, we basically use bridging, and that's where you use L3VNI. When you're talking between two different L3VNIs, we use routing, and that's where you use the L3VNI, right? And all the concept about symmetric, asymmetric IRB, that's pretty important as well. So hope that was useful. Thanks a lot for watching, and do tune in for more videos. Thanks a lot, guys. Bye.